Hello again. Thanks for watching this video and studying your math with me. The topic is linear equations. We'll talk about terminology. We'll solve some linear equations. We'll talk about the three possible outcomes. And we'll talk about a special type of linear equation that is literal equation. As always, you should read the examples in your book and read your book. I'm not doing the examples in your book, so those are additional examples for you to study. And you should start and stop this video to help with your learning. An equation has an equal sign in it and has unknown variables, in this case x's across this. If we're solving an equation, we want to find all numbers that we could substitute for x that make it true. These numbers are solutions or roots of the equation, and if you talk about the set of all those, you call it a solution set. The technique we use to solve equations is we do the same thing to both sides of the equal sign. So we can add or subtract the same thing from both sides. We can also multiply or divide by a non-zero number both sides. And of course, we use our rules of simplification that we studied earlier in this course. In this section, we're talking about linear equations, which look like that. There's a single variable, and that single variable is raised to an exponent of 1. Here's our first example. We're to solve this, so we'll simplify, get x by itself, and solve. So pause the video, work the problem, and then we'll see how you did. Let's see how you did. You should have gotten x equals 6 as an answer. Let's look at another example. Now here you have fractions, and the technique I often recommend, because many of my students don't like fractions a lot, is to multiply both sides by a number big enough to clear all the denominators. It is going to be the least common denominator. In this case, it's going to be 10. So you want to multiply both sides by 10 as perhaps your first step. So pause the video and let's see how you did. You should have gotten x equal minus 10. There are three outcomes. One is just like the one that we talked about. In fact, both examples we talked about, where you solve for x and you get an answer like here x would be 2. That's called a conditional equation. It's also possible, though, for all the variables to drop out and you end up with something that is always true, like this will give you 3 equal 3, and or you can have something that will end up where you have, in this case it would be 0 equal 1, which is not true. That's called a contradiction. This one is called the identity. In practice, what you do is you try to solve them. If you end up with something that is always true, the variables drop out, then that's called an identity, and the solution set is all numbers. If you get like x equal 3, that's called conditional, and if you end up with something, the variables drop out, and you end up with something that is never true, that's a contradiction. I prefer you say no solution, but you also could say the solution set is the null set. So here are some equations. You're supposed to try to solve these and call them identities, conditional, or contradictions. So try to solve them and we'll see how you did. Pause the video. Let's see how you did. And so we end up with a conditional answer here, no solution here, and the solution is all numbers down here in the part C. The next type of thing we're going to do is we'll solve for a specific variable. This is a literal equation, and that means we have a formula, a science formula or a finance formula, that kind of thing. And that's called a literal equation because you have variables, an equation involving mostly letters. Here are some examples, and we'll start with your famous distance equals rate times time. We're solving this for t, so that means at the end of the problem we want to say t is equal to something. We're solving this one for k, we want to have k equal something. We're solving this for y, that's going to be y equals something. Pause the video, do some work, and we'll see how you did. Here the solution set involved factoring out the k, and then I divide both sides by the whole of r squared plus rl, and so that would be my answer. I also write a script s because my s's look like 5s. So ask questions either in guided study group, the Learning Commons, or in class if you're not doing well on these problems. This is an example of some of the literal equations, and I'm introducing the simple interest formula because we're going to use it in the last example. So interest, that is annual interest, is equal to principal, the amount you borrowed, times the annual interest rate, and this is the time. The time has to be in years because the interest rate is in years. There are many other formulas, but that's the one we're going to use in the last example. So I will let you pause this and read it, and then we'll apply what we have to solving this problem. So please work through this problem and see how you do. Let's see how you did. So here's the formula. The principal is this. The annual interest rate was 6%, but that is listed as a decimal. That is 0.06. And you have to change the time from months into years. And we don't use a calculator, so I did these calculations without a calculator, and the answer would be $116.10. In closing, time is precious. Each day must count. Do the math. It will make you strong. Take care, and I will see you in class.